Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala rasulillahi kareem. This problem is related to statics. A round table of weight W stands on three legs, of which the upper ends are attached to its rim, so as to form an equilateral triangle. Show that a body whose weight does not exceed W may be placed anywhere on the table without the risk of toppling it over. In this question, we should consider a round table uniform weight, having uniform weight, and three legs are equidistant from each other, so that they will form a triangle ABC like this, and upper ends are attached to the rim like this, so that rim, so as to form equilateral triangle. We join the point A, B, C, because these points are equidistant from each other. So on joining, we get equilateral triangle. So that a body whose weight does not exceed W, show that we have to show, so that weight does not exceed W may be placed anywhere on the table without the risk of toppling it over. Toppling is over means that it's turnover like this. If we place a weight which exceed W, we have to show that if we put a weight exceed W, then this table will turn over, or toppling it over. We know that here, if we put weight in triangle ABC, then there is no moment. There is no momentum because there is not free axis of rotation. So if we put any weight in this triangle, there is no toppling. So we should consider only the space where since this question is about to generalize anywhere on the table, so not only for this in this triangle, but also we should generalize a weight which can put anywhere on the table without toppling. So we should only consider this portion which is outside the triangle ABC, means this portion, and similarly this portion and this portion which is symmetrical. So it is not necessary we show for every three, but only we will show only for this portion. I will draw a figure on the next page for round table. Round table is ABC. We put leg at point A, leg other end is L, and other second leg is B, BM. Also third leg on the rim of table means circumference of the table, and we should join these points according to question. This form an equilateral triangle. We know that the weight of a uniform table is acts on its center. Center means center of circle of this circular table. Weight of table is given to W, which will act vertically downward, and write it W here. Join this point, which is center of gravity of this table, to point C. Since this triangle is equilateral, so each angle is 60 degree. So we write here 60, and join AG and produce it to point E on the circumference of the table, circular table. Join we should put the weight P. We have to show this weight must be W, which is maximum weight. We put here, and table will not topple down, so which is maximum weight. If we exceed it, then table will turn and topple down. First of all, we write here this solution is given. Not only this question, I am also given the solution of this, so I write according to that. Let ABC be the round table as I draw, in which A, B, C are upper ends of the legs. Attached to the rim means circumference, such that ABC is an equilateral, as I tell you previously. Equilateral triangle, each angle and each side are equal in triangle, we know that. And let LMN, as I show in figure, V, the points of contact of legs with the floor. So all 3 points L, M, also point N lie on the floor. I join the line MN, which is parallel to BC. Also we let G be the center of the table, because table is uniform, therefore weight of table lie on the point G vertically downward of the table, which its weight W acts downward. There is a possibility of any weight P is placed outside the triangle, as I tell you previously, because if any weight we put in triangle ABC, there is no axis of rotation, so the table will not turn about and triple down. So we write here, there is a possibility of any weight P placed outside of the triangle ABC, but we know that the maximum moment tendency of movement means torque when we go farthest to the BC. So it is only on the perpendicular bisector of BC, hence A is the midpoint of arc BC. Also if we join I also join this point and which is perpendicular bisector of BC, and its Mach 90 degree, because BC is a chord. We know that chord is when midpoint of chord is joined to the center of the chord. Here it is denoted by G. If we join it, then according to theorem which we studied in 10 class level, this angle is equal to 90 degree. I write this point which is midpoint of BC as D. So since E point is midpoint E arc of AC is the midpoint of arc AC, so according to theorem D is also the midpoint of BC, which also we know because this triangle is equilateral triangle, and if we join the midpoint of vertex, we the triangle is divided into two equal parts, and this side also equal because a triangle says equilateral triangle, and this side common. Each angle is 90 degree. So we can prove it. These triangles are equivalence by right hypotenuse side. So these angles are equal. Since sum is 60 degree, so these angles are 30. In triangle this ADC, this angle is 90 degree and it's 30. But we want to find this angle. Since arc EC on joining on the center and also it's joined on the point A, we know that on center angle is double to this angle. Since this angle 30 degree, so this angle is equal to 60 degree. By this angle we will able to find this distance, means GD in terms of GC or GE, because G is center of circle, so GC is radius, also GE is radius. But we talk about the this point with which is there is a possibility of any weight P is placed outside the triangle ABC. Say in the portion BEC, BC or AFC or AHB, which is equivalent. So no need here to show for each portion. It is sufficient us to show for this portion BEC because it is symmetrical for all threes. If there is overturning, the table will turn about the line MN, because there are two weight. One weight is weight of table which acts at the point G, which weight is W, and B also put a weight for make it turning, about to turning. So we and for effect is maximum, to make effect is maximum, we put its farthest to the VC. So we choose point E for this, which is the mid of arc BEC. We talk about if there is a overturning, the table will turn about the line MN, and the leg AL will rest very lightly on the floor, like this. If there is overturning point A, B, C. If we put the weight on the point E, which is P, then the moment or torque make this table to turn about the B and C, turn about to line BC, and like this. What weight of this make turn to opposite direction? So these are clockwise and anti-clockwise to torque. In limiting condition, they make equilibrium, and in this case we have to find the weight P and prove it. P is equal to W. So we'll take moment about BC in limiting condition, and taking that both tendency of motion or rotation equal, and by this we will able to find the value of P. For this we have to find the distance from line of rotation BC or MN, which is equal to GD, because W is, which is weight, W is GD distance from BC. Also other weight is P, which is D distance from BC. So we will find the value of distance GD and DE. In that case, the ends L just loses contact with the floor, because in limiting condition if we increase the weight P, then the table will turn down or topple down. So in limiting condition, I'll just lose contact with the floor, and the weight P and W will have equal moment, because we take equilibrium or limiting condition, because after it the table will turn topple down. So in for equilibrium we write here weight P and W will equal moment about Mn, it is about BC, Mn or about BC, which is equal because the perpendicular distance from line BC and line MN from the line of action of force P and W are equal, and moment also equal, also BC parallel to MN, because these are vertical legs of the triangle, so table. The bed P will have a greatest turning, as I tell you previously. The weight P will have the greatest turning effect when placed farthest. So I put on the brim of the table or circumference of the circular table at the point E. For this away from BC, which is only possible when we put it on the perpendicular bisector of BC, because we know that perpendicular bisector of equilateral triangle of any side passes through the third vertex, means here A, and also passes through the center of centroid, or center of gravity of triangle ABC. Away BC, that is when place at E. The midpoint of the arc, this discussion already happened, BEC. This discussion have done. Let D be the midpoint of BC, as triangle ABC is equilateral according to question. AGDE is perpendicular to BC. Because D is midpoint in equilateral triangle, if we join the midpoint to the vertex, then this length or median also perpendicular to the base. So we write here this. It will help us in finding the length which we required in moment. So I taking moments about BC. Here is only two forces which make moments about BC, which are opposite in direction. In equilibrium they are equal and opposite, so we write as, for moment W, we write W, torque or moment is equal to force into distance about from line of rotation, which is equal to GD. We write W into GD. And also for force P, force and perpendicular distance from a line of rotation is equal to DE. Now we have to find the relation between GD and DE. So we go in triangle CDG, and we here see that this triangle is a right angle triangle in which angle D is 90 degree, and we also tell you this angle is 60 because the arc EC make double angle on center at arc join at any point remaining point of the circumference other than EC. We find any point we join this angle, because this angle is 30 degree, so this angle is 60 degree. Not need to describe here on in triangle. We know that for finding GD and in terms of GC, because GC is a fixed radius of circular table, so we find GD in terms of this. For this triangle, this line is opposite, this side opposite to the angle this, so this is hypotenuse. And for this angle, this side is base, because we know opposite side to this angle is perpendicular. So we apply cos 60 here for finding the base, which is equal to base upon hypotenuse. So we write base GD and hypotenuse GC. We note that the value of cos 60 is equal to 1 by 2, and by this we can find GD in terms of GC by transposing GC to left hand side and write it on right hand side. We transpose GC on the left hand side, but write it in right hand side and GD on the left hand side. I write this equation 2, and if we find the value of D, which we have to find here, if in equation 1, we are saying if we subtract GD from G, we get DE. So we write it here GE minus GD. But from equation 2, GD is equal to half of GC. But we see that G is a center of the triangle ABC. Whereas G is equidistance from the point A, C, E, also from E, because center of circle. So we replace GC from GE. We replace GC. So G 1 by 2, we replace G by GE. G minus half G equal to half of G. We write it equation 3 from equation 2 and 3. From 2 and 3 we can write, we see here both is equal to half of G. So these quantities equal to same quantity, so these quantities are equal according to Euclidean geometry. So GD equal to DE. If we place GD in equation number 1, then equation 1 becomes W into dE. We put the value of G in terms of D. What on right hand side equation now there is no change, but this value are equal. D cancel out. We see here P is equal to W. This so that P is equal to W. This so that for equilibrium or in limiting position, the weight W is maximum weight is W is placed on the rim of the triangle, which is maximum. So hence W is the greatest weight. W is the greatest weight that can be placed anywhere on the table without toppling it over. It can be, question is completed here. What we know that for further knowledge, it can be noted that if as we talk about it, it can be noted that if any weight is placed within the triangle ABC, its moment about BC or CA or AB will the same direction as that of W, and hence there is no chance of the table being overturned whatever the weight may be. But if we for the last portion we tell you in starting that if we put any weight in triangle ABC, there is no free axis of rotation, because we put any weight on this weight will we cancel out by resultant of force applied by these legs in upward direction, because we know that the resultant of reaction on B and C passes through the midpoint of BC, because this triangle and legs are symmetrical and weight also is apply on the point W. So the way this passes the resultant reaction of two reactions which apply on the BC passes through midpoint of BC, and resultant of point D and A, which is upward direction, will cancel out or overcome to force W, or any weight which we put here, there is no moment. So we have proved that only weight W which we can put on the rim, which is maximum weight which can be put without toppling it. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.